Right, it's worked. So thank you. My name is Hugo, and aside from being a Google developer expert, I'm also a freelance developer at my company, Little Robots. And today I'm going to talk about RxJava, and some context for this talk. I'm going to talk about RxJava for the rest of us, because I noticed in my projects that I do, a lot of RxJava is already being used, and a lot of people are starting to use RxJava or have been using RxJava already. But a lot of people are also a little bit struggling still with RxJava, because it's not very easy to use, and it doesn't get any easier for me as well. So I'd like to give you a little taste of what RxJava looks like if you haven't used it before. And if you have used it, I will also show you some more real-life examples and some tips and tricks to help you write better RxJava code, basically. So this presentation is about RxJava 2. It's not that relevant for this presentation, but there are some differences. So who has been using RxJava 1 already? Oh, a couple of you. RxJava 2? Also a couple? So yeah, so then in that case it's probably good to point out some differences. So in RxJava 1, and if you don't get any of this on this slide, it's not a problem, I will go into some details later. RxJava 1 had one type called Observable, and that type supported back pressure. Back pressure basically means that if your observable is emitting a lot of events, and if your subscriber can't keep up, there's some strategy involved to make sure that you don't lose these events. In RxJava 2, they split this up in two types, so there's now a flowable and an observable. Flowable is the one supporting back pressure, and observable does not support any back pressure anymore. This actually makes things simpler, so this is a good thing. RxJava 1 and RxJava 2 are using a different package name, so if you are switching from RxJava 1 to 2, you are able to run both in the same app. I'm not sure if you should, but you can. If you have like a huge app and you want to slowly migrate, it's possible. RxJava 2 is also based on the reactive streams specification, which for Android is not that important, I think, but if you're on the server side and using RxJava, that means that you can switch out other implementations of the reactive stream specification for different versions, so that might be nice. Version 2 is a total new rewrite, so it has a lot of learnings from the first version, less allocations, for example, so it should be more efficient. It also has a larger method count, so that might be relevant if your application is just pushing the depth limit already. You might get over now. And RxJava 1 will basically be end of life next year, so definitely start moving towards RxJava 2, because after next year there won't be any support for it. And if you're starting something new, of course, start on version 2 now. Okay, so why would you even use RxJava? Let's look at some typical code. So if you're happy and you have this, you just want to get an article, you call a getter and you get it. If you're writing this kind of code, this is great. You don't have any problems for it. You just get this article and it's done. Usually though, this article is not already available. You need to get it from somewhere. You need to get it from the network, or you need to get it from a database. And then in that case, you are unable to just get it, because you would block the main thread and that would be bad. So what you might end up is getting something like a callback. And how a callback works is that you just execute the method, so things will start processing, so maybe a network call, and once that network call is done, you will get a callback with the result, or maybe an error. And callback works quite nicely, but it has a couple of problems. One of the problems is that it's very hard to, there's no standard way to cancel this callback, so if once you call this method, it's going to run and will return some kind of method. Also, it's hard to orchestrate multiple callbacks. So if you have, first you need to get an article ID, then you need to get the article, and then you need something else. You usually end up writing a callback within a callback within a callback, so it's hard to manage. And a third problem is that it's not really defined on what thread the callback is being run. So when this result comes in, it might be on the background thread, it might be on the main thread, and depending on the case, you might need to switch back to the main thread in your code, which is inconvenient. So we have async task in Android, which is trying to solve some of these problems. So async task, the main intention is to run some process on the background, and once it's done, give you the result on the main thread. So this solves the threading problem, basically. It also allows you to cancel this task, which is convenient because, especially on Android, where you're dealing with the life cycle, you want to stop your task if your activity is destroyed, for example. However, it still has the same problems in dealing with orchestration of multiple callbacks, and there's also no real standard way of handling errors. So async task, well, it's a little bit of an improvement over callbacks, but it's still not the right solution. When we would approach this in a more reactive way, we would write something like this, where we have a method that gets an observable of article, and an observable is in that case just an object that will give us the article once it's available. So you are actually responding to this observable. That's why it's called reactive. You're reacting to something happening. And what's also interesting about this declaration, that once you call this method, nothing is being executed. So unlike the callback where stuff is already starting when you call it, nothing is being executed for an observable. You need to subscribe to this observable before you can get any values out of it. And this is very convenient because you can pass this observable around to other methods. So you can set this up and then pass it to somewhere, and once you are interested, you just subscribe to it. What's also interesting about this declaration is that you can't really tell if this is synchronous or asynchronous. So if you subscribe to this, the result might come in a synchronous fashion, but it might also be asynchronous. If it's asynchronous, it's also cancelable. You can also cancel this observable. And there's built-in error handling. So how does this work? So the observable is also called the stream usually because it's a stream of events basically. And there are three types of events. This is the value event, often called onNext. So the value event in our case will be the article object. So every time an article comes in, you will get this value event. And for an observable, you might get 0, 1, or many articles, depending on the implementation. In RxJava 1 and 2, there are also specialized types that will guarantee you only one or no versions, but that's like this more specialized version, and this is the general case. The second type of event is an error event. If you get an error event, then you're guaranteed that after the error, no other events are coming in. You're actually unsubscribed at that point. So this stream will terminate once an error has happened. And the last type of event that can occur is a completion event, which is similar to an error, but it just means that the stream is terminating without any error happening. So you might get an article, then some more articles, and at some point you'll get a completion event, and at that point there will be no more events. So I mentioned a couple of times that nothing is executed once you create a method, and you actually need to subscribe to it. So in RxJava 2, you do that with the subscribe with method. In RxJava 1 it's called subscribe, and it returns a disposable object. In RxJava 1 it's called a subscription. And what you pass into this function is a subscriber, and that subscriber has a callback for each of the three events that I mentioned. So you have the onNext, we have the onError, which takes a throwable, and again, if this throwable happens, then you're automatically unsubscribed, and we have the completion. And also when that happens, you automatically unsubscribe. There's one slight change from RxJava 1 to RxJava 2. In RxJava 1 you were able to get a value event that was null. In RxJava 2 that is no longer possible. If you try to emit a null event, you'll get a null pointer exception. So this RxJava 2 is more strict in that way. It can be a little bit inconvenient because you now no longer have to. It's more complicated to emit to emit a value that represents something is going away. So if you have an article and then want to emit an event that says, well, there's no longer an article, in Java you would usually use null, but you can't anymore in RxJava 2. So you have to find a different way for that. It's not a really big problem, but it can be a little bit annoying. So another way to subscribe to this thing is by using inner classes. And this is very convenient because you can now optionally implement the ones that you're interested in. So subscribing with inner classes is similar to using a subscriber. You just call the subscribe method, and that takes in consumer. And in RxJava 1 it's called action1, but it's basically the same method signature, just a little bit different name. And then you have these 3 callbacks for your value event, for your error, and for your uncompletion. And again, this returns a disposable which allows you to unsubscribe. And this notation is especially convenient if you combine this with lambda expressions. And when I started this presentation like last year, I was hoping that by now everybody would be using this because of Jack and all kinds of things. But 3 days ago, they announced that Jack is no more, so we're now going to wait on a new implementation of lambdas. But in any case, if you're already using Android Studio, and you all are of course, then this is how this will be displayed in Android Studio as well. So it will prepare you for using the lambdas. And you can also use a tool like retro lambda to already use this syntax. And in this syntax, you subscribe. This is the value event with some action. This is the error with some action, and this is the completion with, again, some action. And for the presentation, I will use this notation as well because it's more concise and will fit on the slides as opposed to using inner classes. So I mentioned a couple of times that you need to unsubscribe when you're no longer interested in this observable. And you do this by calling the dispose method on the disposable that you got when you subscribe. And it's really important that you always unsubscribe when you're no longer interested. Because for various reasons, one reason is that, for example, if your activity is going to be destroyed or your fragment is going to be destroyed and this callback comes in, then you might be in a state where it would crash your app. So that's bad, of course. You want to stop the task once you are no longer interested. But more importantly, if you're using this inner classes syntax, your inner class will hold a reference to your outer class, which is usually something that holds a context. And if you're holding a context, that will mean that you will leak memory if you don't unsubscribe. So it's really important that you always unsubscribe from this observable once you're no longer interested. And therefore, you don't want to lose these subscriptions. You will always keep a reference to it somewhere. So this was like a quick introduction, the basics for RxJava. And personally, I don't think that this stuff is that complicated, right? We just have an observable, we get the events out of it, and at some point we unsubscribe. So that's pretty simple. Yet, RxJava is known for a steep learning curve. And I think it's true. And one of the big reasons why I think there's a steep learning curve in learning RxJava is because it's really an architectural change to your app. So if you are introducing some kind of HTTP library, for example, then what you're basically doing, you could easily write HTTP code yourself, right? It will take you like 30 lines to get some URL. But if you then go out and introduce a library like HTTP, you can do it in 2 lines. So that you're basically destroying all this boilerplate that you have to write yourself. But the actual structure of the code is not changing in that case. You're basically keeping the same structure, same architecture, and nothing is really changing. But if you apply RxJava, then you really need to think in a different way about how you approach this problem. So, for example, take this piece of code where we have the need to get some configuration for a class. And we just going to get it in our initialize method and apply the configuration. There's a little problem here. What if the configuration isn't there yet, if it's null? yeah, then we need to find some way to get it at a later point, right? So we probably need to poll for it in some way. If we make this more reactive, if we change the architecture here, then it's easier to deal with this, because now we just have an observable that provides the configuration, and we can subscribe to it. And we know that once this configuration comes in, then it will just be there and we can apply it. So it's way easier to deal with. On the other hand, we now have a couple of more questions that we need to answer. So how are we going to handle any errors that might occur, and what errors can occur? And do we want to apply the configuration every time it comes in? And what are we going to do about unsubscribing? Because I told you should unsubscribe, so we really should do that, right? It's still easy to change that with RxJava, because you can, for example, say, well, we only are interested in one configuration event. So we can apply this operator, take one, with recess, take only one value. And we can also say something like, if an error occurs, well, then we just return the default config. So this is one way to handle it. And we can also unsubscribe by just calling this destroy method at the appropriate times, right? So all of these questions that I had before, we are now solving, and we're also solving the fact that this configuration might be null at some point. If this configuration is available immediately, this will just work synchronous, basically. But I hope that you can see that this is clearly a different kind of architecture as opposed to the first piece of code. And it takes some time to get in that. You have to rewire your brain a little bit to get into that mode. So another another contributing factor to the steep learning curve, I think, is the functional style. So there's a lot of immutable types, there's chaining of functions, and it's not really Java-like for most people. So if you're new or maybe starting your career as a developer, this might be a little bit intimidating. It's not a big deal, but yeah, it adds to the load. What really adds to the load for RxJava is all the operators that are available. So in RxJava, subscribing to a stream is not that exciting. What you usually want to do is change that stream a little bit. So in our case, we are saying like handle these errors or take only one. So you need to learn all these operators that are available, and there are hundreds of operators. So you have hundreds of operators, but you also have a lot of combination of operators. So you need to know, how do I combine the operators in such a way that it makes sense and they have a nice recipe of doing a certain task. So given that there are hundreds of them, it takes some time to learn them, and it takes some time to know that they exist. Another contributing factor for the steep learning curve, I think, is the documentation. Because there are so many operators, there's a lot of documentation, and the documentation might be a little bit daunting. It's not that it's bad documentation, it's actually pretty good documentation. But if you take an example for one operator, you see there's a lot of generics here, a little bit fuzzy, but a lot of generics. And there's this diagram here, and this diagram is actually supposed to help you understand what the operator does. So let me try to explain you what this diagram shows you. So on the top we have the events coming in, so that are the circles, and this means that this stream is completing. And then in the middle we have our operator, and that changes the stream a little bit. So what FlatMap does is it takes one event and then turns it into a new observable. And this observable might emit 0, 1, or many other events. So in this case, you see that the red circle is transformed into two red diamonds. And you can also tell that this happens for the green and the blue ones. What's interesting though is that the green and the blue ones are interleaved. So apparently this operator is merging various observables. So this is all stuff that's in this diagram, and you need to somehow process that and understand that. And this is just one operator. So if you have 100 operators, you also have about hundreds of diagrams. So yeah, it can be a little bit intimidating. So what I would recommend when you're thinking that RxJava can solve a problem for you is to just start gently, right? Don't try to say like, I have this app, let's use RxJava for everything. Because that usually doesn't really work unless you really know what you're doing. So don't try to go all out reactive. But apply this RxJava code where it makes sense. And I think some areas where it makes sense is, for example, in your domain layer or in your business logic, where you do some data transformation. It's very easy to, it's a nice place if you have some complicated logic to try to apply RxJava there to see if you can get more concise or simpler code out of that. One obvious place to use RxJava is by using REST calls, especially if you're using retrofit. I think most people got involved with RxJava by using retrofit because it had support for RxJava early on. And using retrofit and Observable is very easy to orchestrate these multiple calls. So that's really a good place to use it. Another good place to use it is when coping with life cycles. So if you have something that is started and stopped again, like many Android fragments and activities and that kind of stuff, well, then it makes total sense to use an observable because you can clearly define when you start subscribing, you can clearly define when you stop subscribing. And with that, you sort of get a more specialized event bus. So instead of an event bus where you pump out all these events of all of your apps and you have no clue where they're coming from, you can now have an observable for these events and then subscribe to the ones that you are interested in. You can also use this in the UI layer, of course, but for me, especially also when you combine this with when you use data binding, there are not that many use cases, but yeah, it really depends on your app, of course. But if you just want to start with it, I would recommend to apply it in the other areas. Okay, so what I would like to do now is give you two examples of how I'm using RxJava in our app. And our app is an app where we scan clothing using RFID scanners in a shop. And this is used to verify that everything is in stock, right? So we have like a scanner, we scan t-shirts and we see, oh, we have 5 t-shirts of white t-shirts and we have like 10 green t-shirts, for example. So in that app we have many observables of articles. So an article in this case is a physical t-shirt or a pants or whatever you find in a clothing store. And what we want to do in this case, we want to map this article into the RFID tag. Well, there's a simple operator to do that. So we get this observable of articles, and what map does, it takes a value event and converts it into another value event. So we have this article, and you're going to return the RFID tag. And by doing that, we're just mapping an article to a string, right? So this is all there is to it. One thing to realize here is if you call observable of map, you're creating a new observable. So you're not changing the existing one, you're creating a new one that will decorate, so to say, the existing observable. And again, when you call this, nothing is being executed, only if you subscribe to it. So this is like the functional style where this thing is not, this observable is not really modified, but it's creating a new observable. So this was a pretty simple example, right? You could easily do this with a for loop, for example. You don't really need reactive programming here. We're now going to look at a more complicated example. So in this example, we have our clothing store and we want to process only the articles that are supposed to be in stock. And then for every article that I scan, I want to group the articles, and eventually I want to emit a count of articles by type. So if I scan 5 white t-shirts and I scan 10 green t-shirts, I want to have 2 events out of this observable of article quantity, and it will tell me that I have 5 white t-shirts and 10 green ones. So this is the code. So let it sink in for 1 second. And I don't want to necessarily tell you that this is easy. I don't think it's easy. This is code that took me some while to understand as well, but I will talk you through it. So first step we're going to do is we're going to filter this observable that we are getting in. We're going to filter it by all the articles that are in stock. It's pretty simple. We have here a boolean is in stock. If it's true, then it makes it filtered. So by doing this, we're creating a new observable that now only contains the articles that are supposed to be in stock. And then we're going to group it. And group by is another operator that takes a function in this case of article, and needs to return a key, a string in this case. And so the key defines what group it is. And let me show the marble diagram for this. And when I saw this the first time, I was like, what is this? I had no clue. What this does is it takes these value events, so these squares and these triangles, and it will then create new value events. It will transform it, but it will not be normal value events. It will actually be new observables. So these circles are now grouped in a new observable of only circles. So this is kind of mind-blowing, but after we apply the group by, we now have an observable that emits new observables. Okay. So bear with me. Now we want to process each group individually, because we want to count how many articles we have in each group. For that, we can use the flatmap operator that we already saw. So flatmap takes an event and then it turns it into a new observable. And for this type, we are now going to take the group. So the group is a group observable, which has the key and the collection of all the values in that group. And now we're going to map each article in that group to a new object. So this is the same map that we saw before. So what we're going to do, we're going to take each article in that group and we're going to transform it into an article quantity. Because that's the eventual object that I want. I want to have an object that has the count of all the articles. So after I've done this, I now have an observable for each group that will have a value event of article quantity. So if I have five t-shirts here, 5 white t-shirts, I will get 5 events, article quantity 1. So I'm almost where I want to be, but I don't want to have 5 article quantity events, I want to have 1 for each group. So I can apply another operator here, and that operator is called reduce, and reduce will, reduce all these values into 1. And it's pretty simple. We take 2 of these values and then we create a new one. So we can easily just sum up the quantities that we saw, and that will result in one object for the whole group. So we have filtered, we have grouped them, then we applied each group, and for each group we turned the whole group into one event. And that will eventually give us the solution. And again, I'm not telling you that is easy, right? I'm also showing this because when you're new to a project that uses RxJava, this might be code that you run into. And this is not really trivial. You have to think about it, you have to understand it. And also if you're in a team with junior developers, for example, it takes some time to learn this. You can't really expect from any starting developer to, hey, this is my grouping code. Good luck. So getting here is, of course, you have to ask yourself some questions. Well, how do I convert from this type to that type? And what operators do I need to learn? In this case, we already have 5 operators. Another important thing that I need to know when applying group by, for example, here is that the group by requires my stream to complete. So if I have like an endless stream of articles, this won't work because the group by needs to see every value in the group in order to work. So the goal of this example is not so much to show you the exact code, but just give you an impression of what you can do here, and also understand that it's powerful, very powerful. Put any observable article in there, and it will just do the transformation for you. This may come from the network, may come from the database, may come from any list. So it's very powerful, but it's not trivial. Okay. Let's move on. Because so far I didn't really discuss the threading side of things. That previous example, if this observable comes from the network and you subscribe to it from the main thread, then the effect will be that it will go out to the network and do that call. But on Android you can't really do network calls on the main thread because it will crash your app. So you need to have a way to control on which thread you are calling this method. And for that we have schedulers. And a scheduler is basically a worker that you apply to your observable, and then this controls on what thread things are running. And there are a couple of built-in ones. So you have the schedulers.io, you have schedulers computation. So depending on the type of work you pick, whatever is suitable. But you can also create your own one. If you have like a specific need and you want to create, for example, a thread pool with a limited amount of threads, you can do that. For Android, there's a very convenient one from RxAndroid. It's called main thread, and that is obviously the one that you're going to use to make sure that your result comes back on the main thread. There are two operators for applying these schedulers, and they're called subscribe on and observe on. And it's important to understand that subscribe on is the operator that controls where the work is being done when you subscribe to the observable. So if you have something that does a network call, you would use subscribe on to make sure that that network call happens on the particular thread. This also means that you can apply subscribe on only once, because it doesn't really make sense to apply it multiple times, because you will be creating a thread, and that will be creating another thread, another thread, until it does the work. So it's kind of wasteful to apply it multiple times. Observe on the other hand, controls where the value is emitted, on what thread the value comes in. So you can use observe on multiple times. And in this example, we have subscribe on the map, and so subscribe on would apply to everything to the left of that operator. So the observable map will now work on the background thread. Then we have the observe on here, and we have specified main thread. So everything to the right here will now run on this main thread. This is very useful because you now have this call being on the background thread. We switch to the main thread, do some other processing, and we can now easily control the views. If you would have something that's more resource intensive, you could switch back later again to some background thread and then eventually go back to the main thread, for example. There's one caveat, and that is that some operators have their own scheduler. So even if you are a good citizen and have this observe on, if you would apply timer somewhere, for example, then it will bring its own scheduler, and it will still be on the wrong thread if you want to touch your views. But in all these cases, you can also supply your own scheduler for the timer, for example, but it's something that you need to be aware of. So let's look at some common mistakes that I might or might not have made in the past, but also some mistakes that I'm seeing in code for teammates and code reviews and that kind of stuff. So one of the biggest mistakes, especially when you're starting out, is forgetting to keep references to your subscriptions. Again, if you forget to keep a reference, you're unable to cancel the operation and you risk memory leaks or crashes. So one nice technique to handle these subscriptions is to have a class called composite disposable, or in RxJava 1 it's called composite subscription. And this object is basically a collection of all your subscriptions. So what you can do is on start, for example, you can add your subscription to this object. And once you are done with, or once you want to cancel all of the operations at the same time, you just call clear on that object. So in this case, we're starting the work in onStart, so it makes sense to stop it in onStop. And then we call clear. It's kind of tricky still because there's also a dispose on this object. or unsubscribe if you're using RxJava 1. But you shouldn't use that for Android, because if you do that, then basically your object is unusable. If you call dispose here and then on start, then this thing would be immediately unsubscribed. So you always want to use clear and not dispose. So another common mistake is not handling errors. Especially when you're using the callbacks, the inner classes variant. All these inner classes are optional. If you forget to handle the errors there, then especially if you apply a scheduler, you will get this stack trace showing you that something went wrong, but you have no clue where you subscribe to it, because it's not in the stack trace. It's just showing, well, something happened. So yeah, always try to always supply this error callback. Otherwise you'll be staring at this stack trace in Crashlytics and you go, oh, I have no idea. And even if you're logging these, if you're handling these errors, it's also important to log the specific error, because in your on error callback you get this throwable, and it can be anything. And maybe you're expecting like io exception or some other exception, but if you make a mistake somewhere in your observable, it might be a null pointer exception, for example. So if you don't log that exception, you'll look at your app and you see, oh, why is nothing happening? And I don't see any errors. So, because I'm handling these errors. But in fact, there's some error being swallowed, basically. So always try to log them. I've also created a lint check for RxJava code called rxlint, which will flag your code and make it red if you forget to add these error callbacks. So yeah, there are also other tools doing that. If you use error prone, for example, it will also flag the code. And this is, I didn't do this, right? So I see this in code reviews. Some people are really, they are like, yeah, I'm understanding this RxJava thing. It's really cool. I know how to create an observable, I'll subscribe to it, apply some operators to it, then I'll just subscribe to it and post all of my results on the event bus. But what you're doing there is just creating a very complicated way of an async task. It's not using any of these observable features. You can't even cancel this. So what you should do, of course, is just get the same observable, apply the schedulers, that was good, and then just subscribe to it, and then get the values and get the error. In this way, you can still unsubscribe from it. But I've seen it a couple of times, so I thought I would mention it. Another thing that might be tempting when working with observables is what I call breaking the stream. So if you are in some kind of operator, like map, it might be tempting to call out to some other function that doesn't really to control it. If you really want to do some side effects, it's fine. There are some operators for that to do it. It's called do on something. So for example, we have to do on next. So if you want to log every value that comes out of the stream, you can use do on next. And if you really want to do something like this, then you probably want to use flatmap, because flatmap allows you to create a new return a new observable, and often you just combine the value that you got in the map with the flatmap result. So yeah, if you find yourself doing this, that's a red flag. Don't do it, because again, this will get you into the situation that you might call all kinds of methods and crash your app. All right, I have also a couple of tips. One big tip is, if you're writing this RxJava code, you might find yourself in a situation that you have this observable, and you need to apply some operators, and you need to apply some more operators, and before you know it, you have this method with like, I don't know, hundreds of lines. So it's probably way easier to try to break up these steps in multiple methods. That helps for testing, because you can now test each individual step. You can also test it in a synchronous way. And it also helps for understanding what this thing is doing. So you can just compose your observable from multiple functions. And of course, this is like a common practice. If you wouldn't be writing a method with 100 lines of code usually, you just call other methods. But if you're in RxJava code, it might be tempting to forget that advice. So I just wanted to call it out here. Another tip is to apply your schedulers as late as possible. Again, it also helps testing. So if you're having an observable that doesn't have any schedulers involved, then you can easily test it because it's synchronous. You can block for it, and in your test you make it blocking, and you just get the result. It's harder when you have these schedulers involved, because then you need to apply a test scheduler and do more work in your test. Also, if you see yourself doing this all the time, like creating an observable and then subscribe on observe on subscribe, it might be easier to do that in the place where you're calling this thing all the time. So if you have this retrieve article, and it basically always needs to run on the io thread and always needs to return on the main thread, just do it in that function. That makes your other code simpler, and it also allows you to change the scheduler if you need to in one place instead of all over your app. And here's another tip, especially for RxJava 2. On RxJava 1, there would be situations where an error might occur and RxJava would just swallow it. And these errors in particular are called lifecycle errors. So if you have an observable, you can create your own observable, but you might, for example, if you do a merge is like you have multiple observables and you merge them together. So that might be a situation. So if an error occurs, after an error is being emitted, it's no longer allowed to emit another error because the stream is terminated at that point. If that would happen in RxJava 1, it would just silently ignore that error, so nothing would happen. RxJava 2 is more strict. It says, well, something happened, so I need to tell you about it. So it will throw an exception. And it will be an undeliverable exception. And then, so on the one hand, it's doing the right thing by telling you this exception. On the other hand, these are exceptions that you cannot always avoid. If we're in the case for the merge, for example, if we are merging a couple of HTTP calls and they all time out about the same time, they might throw an error at the same time, and the first error will get to your error handler, and the other ones will turn into undeliverable exceptions. So one thing you can do here is add an error handler that checks for the undeliverable exception, and if it's undeliverable, then you just log it somewhere, maybe to Crashlytics or your Fabric or to your Firebase logging, or to Logcat at least. And then in all other cases, you just get the current thread handler and then emit the error there. That's probably a safe way and probably something that you need to do in most apps using RxJava 2. This has been there since RxJava 2.06. Before then, it will just crash your app and you have no idea why. So, but now it's solved, fortunately. Okay, this is my last tip. At one point, you might be really like, yeah, I'm getting this. This RxJava is great. I'm going to use it for everything. So in this case, we're getting this list. We turn it into an observable, and then we subscribe to it, and we do something with the article for every value. And this just works, right? It's fine. The code is fine. There's no problem here. But what you're doing here is just rewriting a for loop in a more or less complicated way. So if you are liking this functional style, you probably need to switch to a more functional language like Kotlin. So I would recommend against doing this too much in your app. It's fine to do this in the context of a flat app, for example. If you need to turn a list into an observable, then you do this. But it's in your stream in that case, it's not separate code. So yeah, that was my tip. So leading up to the conclusion then, I think RxJava is a very valuable and powerful tool to have in your Android tool chest, so to say. But it does take a lot of time to understand it and to learn it. And even if you work with RxJava for a while, there might be situations where you are surprised about this framework and what it does. So I would really recommend to take small steps learning it, and in that case you will be fine, I think. So with that, my presentation is complete. If you have any questions, I'm happy to take questions. Thank you.